So our systems that we're going to be working with today are the linear quadratics. These are the systems that we're working with. That means you guys are going to have a line and you're going to have a parabola. You should remember how to graph lines from Algebra 1, so I'm not really going to do that. But for quadratics, we learned that at the beginning of Unit 2, our last unit. So you guys will be seeing quadratics in standard form or vertex form, so you have to remember how to graph those. So when you guys are solving for a system, just in general, to set the stage here, when you're solving for a system, you're looking for the points of intersection. The points of intersection of the function. When you're solving a system, you're looking to see what x's do they have in common, what y's do they have in common. So the best way to describe it visually is where the two graphs, if you were to graph them on a coordinate plane, is where they cross, their points of intersection. So I've highlighted this because it's really important. When you guys write the solutions for a system, it should always be a point, like an ordered pair, like this. Right? Because the solution is a point. It's where the two graphs cross. It's the place where they have the x and the y in common, which is where the two graphs are intersecting. So whenever you guys give me a solution, it should be as an ordered pair, an x, comma, y. There are three different ways to solve a system. You guys can solve by graphing. Right? That's the really visual graphing. You can solve by graphing, that's the visual one. It's where I give you a line, I give you a parabola, you graph both of them, and you visually use your eyes to see where's that point where they're crossing. That's the visual one. Then you guys have the substitution method. I feel each year that most of my students prefer this method. I personally prefer the elimination method. But one algebraic method is the substitution method. The other one is called the elimination method. I will be teaching you both the substitution and elimination methods, but for the most part, you guys are able to choose which one you would rather use. Sometimes elimination works a lot better than substitution just because of the way that the function works out, but again, it's going to be your choice on which one you would like to use. Okay, so you can find which one kind of clicks with you. All right, we're going to start with the easiest one first, which is the graphing. So just to introduce, you have three different possibilities for solutions. You could have your parabola and your line meet two times. If they intersect two times, how many solutions do you have? Two. You have this situation where the line only touches the parabola once, in which case you would have how many solutions? One. It's only one intersection. Or you could have the line like this, where it's not touching the parabola at all, and that would be when you have no solutions. Okay, so you only have two, one, or no solutions, and it depends on how everything works out when you graph it. Okay, so we're going to start with our first method here, the linear quadratic graphing. So here is your process. Two little bullets. You're going to make sure that those equations are in the form y equals. If they're not already in the form y equals and everything else is on the other side, then you need to rearrange it so that is happening. And then you're going to graph both equations and find the point where they intersect. So one of them is going to be a line and one of them is going to be a parabola for this lesson. Okay? So both of my equations are already in the y equals format, so I don't need to worry about it. All right, let's start with the easy one first. How do I graph that line? Think back to Algebra 1. Okay, so 7 is the line, so that's 1, 2, 3, 4, 5, 6, 7 right here. The number at the end. And then how do I get the rest of the line? Okay, so the slope is the number is m in front of the x, it's negative 1 over 1. And then go down 1 over 1, down 1 over 1, down 1 over 1. And this is a straight line. This is not an absolute value, so you don't have that x, it's just a straight line. There's a very big difference between the absolute value and a line. You have one consistent slope all the way through. That's where you should be graphing. Following along. Alright, so you guys need to remember how to graph lines. If you don't remember, go over to that. Alright, so that's the line, and then we have our parabola. How do I know which one's the line and which one's the parabola? Not square root, squared. Okay, we have an x squared x, and then a term that doesn't have a variable. That's a quadratic in standard form. So you need to be able to recognize just by looking which one is the line, which one is the parabola. So this one's my quadratic. You guys remember how to graph that when it's in standard form? you have to find the vertex, right? You have to find that pointy part so you can create the U. How do I find a vertex in standard form? The negative b over 2a thing. I'll do my work over here. That little miniature formula you have to memorize. So b is negative 6, so if I do negative 6, that would be positive 6 over 1, 3. So that's my x value, and that's how you find the x of your vertex. But isn't a point an x and a y? Okay, so if I know that the x is 3, how do I find the y value? You plug it in. So I'm going to take 3, and I'm going to plug it in here. I'm going to do that mentally. So it's going to go all right again. 9 minus 18 plus 7. Negative 9 plus that negative 2. So my vertex is going to be 3 comma negative 2. Again, this is all stuff you should already know. I'm not introducing anything new. You guys should know this already. I'm going to go quickly. If you don't remember, you guys need to review your notes. So this is the vertex of the parabola. I'm going to go to 3, negative 2. Oops, right there. Then remember how to actually graph the rest of it. The 1a, 3a, 5a rule, where you take 1, 3, and 5, and you multiply them times whatever a was, which is the number of the front. What's the number of the very, very front? 1. So it's just going to be 1, 3, and 5. You're not going to change those numbers. So you're going to go up 1 over 1, up 3 over 1, and up 5 over 1 on the right, and then you're going to do that same exact pattern on the left. When I draw my parabola, it looks like this. I apologize for not blocking it with the board and starting to get it exact. Wow. Not right up. But anyway, that is a parabola. You guys notice that they cross at any point?
Twice.
They cross twice, right? They cross right here, and they cross right here. It's a really good idea to get a habit of circling them so that it's easier for me and for you to know what it is exactly, what the solutions are. So what would this solution be, this one point of intersection? 5, 2, looks like. That's this guy right here, and then what's the other point of intersection? And so that's all I'm looking for. If I ask you to solve a system by graphing, you're going to put both of the equations onto the graph and look for where they're crossing. That's all it is. Very simple. All right, what about example 2? Is everything set up?
That's very short. You got to put y.
I'm going to have to rearrange this so that it's y equals. You can't graph it unless it's y equals everything else. So I think the best way to do this would be to add the y over here and subtract 4x. We don't need to put a 0 there if you don't want to. I'm going to add the y over here, so y is on the left. And I'm going to leave the negative x squared, and I'm going to subtract the 4x over. So basically swapping the y and the 4x where they are, like that. Now this is what my equation turns into. You don't have to add plus 4, just acknowledge that there's no c. Alright, so now that I've done that, I'm going to cross this one out because I don't need it anymore. Alright, which one is the line and which one's the parabola? How do you know the bottom one is the line? Exactly. It does not have a square. That's what makes it a line. It's just mx plus b. Okay? Let's go ahead and graph that one first. Let's do the easy one first. So how would I graph that line? Alright, so the intercept is 5. 1, 2, 3, 4, 5. There we go. Then what?
2 over 1.
The slope is 2, so rise over run, so I go up 2 over 1, up 2 over 1, and you go in the other direction as well. You guys want to be as thorough as possible, so put as many points on the graph as you possibly can, because any one of those could be one of the solutions, and if you graph the point, it makes it easier to see. So when you guys are actually graphing the line, do as many points as you can fit on the graph. Don't just wing it, because then it'll be really hard to spot the intersection. Alright, now on to the parabola. How do I know this one is a parabola? Quadratic. It has an x squared as well as an x. And b, which is 0. But how would I graph that?
Well, first you got to do negative b over 2, so 4 divided by negative
4 divided by negative 2, and you plug in b and a. So that's Negative 2. So the x value is negative 2. First, we have a point, we need an x and a y. So how do I find the y? Plug negative 2 into your function. So it looks like this if you want to write out the work. Find the y. That'd be negative 4. So that should be positive 4. That's what I'm getting.
Yeah.
Oh, because that's a plus. No, because this is 4, negative 4, plus 8 is 4. Okay, so negative 2, and then y is 4. Done. 1, 2, 1, 2, 3, 4. There's the vertex of my parabola. Yeah, when you're squaring x is a negative. You have to make sure you put parentheses around it. Anyways, does everybody understand how I got that vertex? Again, that's not new, old stuff from the beginning of Unit 2. Alright, how do I get the rest of the shape of the parabola? The 1, 3, 5 rule. Now, it's not always just 1, 3, 5. What do you have to do with 1, 3, 5? Multiply times a. What is a in this scenario? Negative 1. The number at the very front of the expression is negative 1. So I'm going to multiply 1, 3, and 5 times negative 1. Which would be negative 1, negative 3, negative 5. So I go down 1 over 1, down 3 over 1, and down 5, 1, 2, 3, 4, 5 over 1. Then same thing on the left side. 1, 2, 3, 4, 5. And I do expect you to actually fully graph them. I understand it's easy to see where the points of intersection are as you guys are counting, but part of the question is actually graphing it to make sure that you finish the whole process. Alright, so now that I've graphed this, I can see that there is 1, 2 points of intersection, and I would like you to write them both down. You're not done until you actually tell me what the solutions are for solving. So what are the intersections? Negative 1, 3. Okay. I'm trusting that you counted that correctly. That looks about right. Alright, pretty simple. You guys just need to remember how to graph things. So if you're having trouble with the parabolas, then you go back and review that. But that's essentially all that is. Okay? Alright, now I'm not going to talk about this, just like I didn't really talk about the calculator stuff last time. If you guys would like to use your calculator to check your answer, do not use it as your primary source of solving. If you want to use your TI device, this would be the process you would follow to check your answer. You're essentially just graphing them into your y equals window. Then there's a special program or function here that acts to find the intersections. So you would set like you tell the function which is tell the calculator which is your first function and second function, and then it'll tell you what the points of intersection are. You just have to do it twice. If there are more than one intersection, you have to do the whole process for this one and then repeat it for that one. So that's how you guys can use your graphing calculator, your TI device. It's actually easier to do in Desmos. So if you guys are doing this at home for homework, it's easier to just go to Desmos, type in the equations, y equals, just type them in, and then you'll see them graph for you, and you just click the point of intersection, and it tells you what it is. So it's easier to do on Desmos, but again, when you guys get into higher level math and you don't use Desmos, it's still nice to know how to use the calculator to do this. So that's an option for you guys to learn and use to check your answer. You could also test that with Desmos. Alright, so we're going to move to the next page. That was the graphing. So again, that's really visual. It's easier to do because it's stuff that you guys should already know how to do, like graphing lines, graphing parabolas. Now we're going to talk about the two different ways to solve algebraic, which again, I'm going to teach you guys both, I'm going to show you both, and then you guys are going to figure out which one would work best for you. So one method is called substitution, the other one is called elimination. This is the process you guys will follow for the substitution. We're going to rearrange both equations so that they're in the form y equals everything else. So just like what we did for graphing. We want it to be y equals and then everything else on the other side. The reason why we do that is because you guys have two equations that say y equals, right? If I say that y equals smiley face and y equals heart, if both of these things equal y, wouldn't they be equal to each other?
Yeah.
you remember the transitive property? If A equals B and B equals C, then A equals C. Transitive property. That's essentially what we're doing here. If you set both of the equations so that they're both y equal, that means that whatever is on the right-hand side of the equation, those are going to be equal to each other. So you could say that. And that's what we're going to be doing here, but with numbers and stuff. Okay? So you're going to substitute one expression for the y into the second equation, which is essentially taking all the x expressions on the right-hand side, just setting them equal to each other, and then you're going to solve. And you guys will be using factoring for the most part to solve. Okay, so don't be surprised. Again, factoring comes back and uses a lot. So we're going to be using factoring to solve for the most part. Then after you guys find the y values, remember how your solutions are points? When you stop at x, what is involved in a point?
A y.
X and a y. So once you find the x's, you're going to take your x values, plug them back in, find your y's, and then once you have both of those, you're going to write your solutions as one. Okay, that's all it is. So let's go ahead and take a look at the first one. Both of our equations are already set up as y equals to. I like to put little check marks already set up the way that I want them to be set up. So they're already set up as y equals. So then I go straight to my second step. Because these are both equal to y, they equal to each other. Yes, property. So the first thing I'm going to do is I'm going to say that negative x squared plus 5x plus 6 is equal to x. Both of these things are equal to each other because they're both equal to y. Just like this little diagram up here. Okay. Now I only have one variable, just x, so that will help me solve. How do I solve that? Think back to what we did at the end of last year. Okay, so I have something on both sides of the equation, which is how you have to start, but I eventually want everything on one side of the equation in order to solve, right? So we talked about last time, everything has to be on one side of the equation to solve. So how do I do that? Okay, so then I'm going to pull everything over to this side, so I have negative x squared, then plus 4x, and then the 6 is just canceled. Then I have this. So since I'm equal to each other, then I move one to the other side, so everything's kind of together in order to solve. Don't go straight here, because you're going to confuse yourself. So start here and then work your way to one side of the equation. How would I solve that?
Negative x.
More specifically, what do you mean by divide? GCF, so factoring, right? So we're factoring out the GCF, which happens to be negative x, because the negative at the front is will have an x. That would leave this behind. Remember, like I said, use factoring, almost always factoring. Sometimes quadratic formula, but I probably will not give you that kind of scenario because that's just ugly. So for the most part, you guys will be factoring. So I use GCF factoring to pull out the negative x. I'm done. I am done factoring, so then how would I solve? You guys remember what the extra step?
X minus 4 equals 0, x plus 4 equals.
There's a bunch of different people talking. There you did. Yeah, you set your factors equal to 0. Remember the extra step, when you guys are solving by factoring, the extra step is to take both of your factors that have an x involved and set them equal to 0. So I have negative x equals 0, and I have x minus 4 equals 0. Don't invent new factors. If it's not there, don't write a new factor. Okay? So I have two factors, the GCF and the one in parentheses that says both equal to 0. What do I get from this one? What value is that?
0.
Okay, so this one gives me that x is 0. What about this one? Okay, so I have 0 and 4 as my x values. Now would I stop here?
No.
No. It's a system. You guys have two equations, that means you need to have two parts to your solution. You have the x and the y. So now that I know the x's are 0 and 4, how do I find the y? You're going to plug them in. Which one do you think would be nicer to plug into? Yeah. You can just pick which one looks nicer. This one's shorter, so it's probably easier to plug into. And you can even just do it in your head if you'd like. So if x is 0 and you plug that in, what would you get for y? I don't want to invent my space here. So one of my y's would be 6, and the other one, if I plug in the 4, would be 6. Now all you have to do is make sure that you match the correct x to the correct y and then write as a point. So if I have 0, 0, 6, and 4, 10. That's my solution. So once you find the x's by factoring, you plug them in to find the y's, and you link them together to create your problem. That's it. Pretty basic, as long as you know your factoring. If you don't know your factoring, then flip it to me. But your factoring is so important. You need to know how to do it. Alright, what about example number 2?
You have to chain equation.
Which one?
Bottom.
Okay. This one is already y equals. Is the bottom one already y equals?
No.
No. So I'm going to have to rewrite that. You're going to take the y on the left, and then you're going to subtract both of the other things to the other side. And then once I'm done with that, I'm going to cross it out so I don't accidentally use it again. Alright, so once both of your equations are set equal to y, then you guys are good. You have to do that first. Alright, once they're both set equal to y, what do I do next? Set them equal to each other. Because if they're both equal to y, then they're equal to each other. So x squared plus 2x minus 1 is equal to negative 2x minus 1. If you have your equations, set them equal to each other. Now what do I want to do?
Get it all on one side.
Everything needs to be on one side. Once you get rid of the y, that's the whole point of the substitution method, is that you no longer have y involved. You're only working with x as your variable. Once you have that standard with only one variable, then you're going to put everything on one side so you can solve. So I'm going to add the 2x. I'm going to add the 5. And that gives me this expression right here. How would I work with that?
GCS.
Is there a GCS?
No. So now you do A times C.
Okay, so there is no GCS. Always check that first. There is no GCS. So this is one of the trinomials in standard form. You guys remember the process we used for the trinomials in standard form? The x, right? The a, b's, and c's, and then with the x. So I multiply the first and the last number.
4.
And then the middle number.
4.
Okay, so what do I do?
2 times 2.
So I need two numbers that multiply to get 4, add to get 4. Do it to me, right? Then what? So instead of writing the middle term as 4x, I'm going to use the two numbers that I just found, 2 and 2. Split it into two parts. Split it down the middle.
X.
Okay.
X plus 2. 2. X.
How do you self-check that you're doing it correctly?
They're the same.
These are the same, right? Okay. So then what's my final representation of the factors?
X plus 2 squared.
It is x plus 2 squared, yes, but it would be easier for you to solve if you write it like this. Okay. So once I finish solving, once I finish factoring, how do I do the solving bit? You set each of these equals to 0. What do I get for x?
Negative 2.
Negative 2. Now you get negative 2 twice, right?
Yes.
Okay, if you get the same number twice, don't write it twice. The answer is negative 2 for x. So if you guys get a repeat number that's identical, that means you really just have one solution. Remember how we talked about those pictures? You could have 2, 1, or no solution? This is an example where you had 2 intersections. This is an example where you have 1. So if you get a number repeated, that means it's just the same number. So it's just negative 2. So remember, you have to find the y as well. So how do I find the y? Plug that into your favorite of the two equations. You could plug it into this one if you like that one better. It's perfectly fine. It doesn't matter which one. But if I plug it in, let's say I plug it into the bottom one, negative 2 times negative 2 is positive 4 minus 5. So what is my solution? You just better write it as a point. You have your x and your y, and then you write them in it as an ordered pair. Like that. Okay? Alright, I'm going to leave you guys to do the last one by yourself. See if you can do the last one. And then we'll move on to the elimination method. Alright. You guys should have ended with negative 3 is 0 and 1 here. Those are the two solutions you should have got. From the factoring, you would have got negative 3 and 1, and when you plug those in, you get 0 and 8. Okay? again, that was just another one. You set them equal to each other after you rearrange this first one. You add the x squared over, set them equal to each other, move everything to one side, factor, etc., etc. So hopefully you got those two solutions. If you need help with that once you finish, I can go over that with that problem with you. But for now, we're going to move on to the elimination method. So this method is a little bit different. The beginning is different, but the rest of it is going to be the exact same as the substitution method. It's just a setup and how you work with the setup situation. The elimination method is really designed for situations where if you were trying to solve for y, like in the substitution method, you would have a coefficient in front of the y that if you tried to divide it, you would get fractions. Fractions are never good to work with when you guys are trying to use the substitution method and eventually factoring. So that's why we created the elimination method. It's really best for situations, and you would have to use this instead of substitution. It's when you're trying to get rid of coefficients of y, but if you divide, you get a fraction. So that's what these examples are going to look like. So you're going to rearrange both equations so that they're in the form y equals everything else. So for this situation, I just want to say you can have a coefficient. You might want to add that in. Okay. For the substitution method, when you guys set it so it's y equals everything else, it should literally just be y. There should be no coefficients attached to the y. But for the elimination method, a coefficient in front of the y is actually okay. You don't want to try to get rid of that because, again, that's the situation for elimination. Is if you try to get rid of the coefficient, you get fractions. So you're going to get y and whatever coefficient on one side, everything else on the other. You want to have the matching terms from each equation lined up, and I'll show you what I mean by that in a second. And then, yeah, leave the coefficients with y. Then you guys are going to multiply one or both of the functions so that the coefficients of y are opposites. You want them to be the same number but opposite signs. Because after you do that, we're going to... oh, alright, this is wrong. Actually, I was trying to do this a different way last year and it didn't work very well. So sorry. Are opposite. That's what goes in the line. Sorry. So you're going to multiply one or both of the equations by the number that will make the coefficients of y's opposite. You want the coefficients to be opposite. And then what you're going to do is you're going to add the two functions together so that those opposite coefficients cancel out and y's disappear. And then once you have all the other terms combined, you'll notice that they're just x's. So from there, you guys would factor to solve just like you would for the substitution method. So it's really just the beginning part. We were trying to pull everything together into one equation instead of two. That it's different, but after you have that, everything else is the same because you're going to factor. Once you've got x's, you plug them in. It's all exactly the same thing. So let's take a look at this example right here. Okay, this example. If I were to try to use the substitution method, this equation would be great, right? This is already y equals 5. This one, if you guys try to use the substitution method, wouldn't I need to divide by -4 so it's just y? But if I divide by -4, does -3 divided by -4 become a whole number? No, it becomes a really ugly fraction, and you have to work with that to try to factor to see gross and awful. So this is a situation where you guys have to use elimination. Substitution is really not going to work for you. It's going to be really sloppy, it'll be easy to make mistakes. When you have this scenario, this is prime example for using the elimination method. What you guys want to do is make these two coefficients opposite. So if this one is -4, what would the opposite of that be?
4.
Positive 4. So that means that I'm going to take my top equation and I'm going to multiply everything times 4. Again, we're trying to get the numbers in front of the y to be opposite, so they'll cancel each other out. If I multiply everything in the top equation by 4, what would I get? 4y. 4x squared. 64. And then the bottom equation is totally fine. I'm not going to change anything about the bottom equation. Just going to rewrite it. Now, this is what I meant by lining everything up. Right? This is a -3x. Does that have a square on it?
No.
No. So I'm going to leave a little space under here empty, and I'm going to put the -3x right here, so it's kind of in between. And then I have the plus 12 right here. So it's a little idea that I have where you're aligning everything in columns. If you don't have an x squared in the bottom equation, leave the space underneath that empty, so you don't accidentally try to combine them because they're not like terms. I've seen kids in the past try to combine these two. because they're next to each other in the equation. But don't do that, because they are not. Once you write that out, I like to draw a line. You guys don't have to, but I like to draw a little line right here. Then you guys are just going to add down. What happens when you add 4y and negative 4y?
Just comes on.
It is 0. That was the entire point of this process. That's what we were after, to get the y's against left. That's the whole point of the elimination method. I have eliminated y. Then I'm going to keep adding down. I have 4x squared plus nothing, because there is not another x squared. That works weird. Down a little. There we go. Alright. Then I have negative 3x. Is there an x term in the top equation? There's nothing to add to that, so just say 3x. But then I have a negative 64 and a 12. Are those like terms?
Yeah.
So what would you do if you add those? I would factor. So this is where the substitution and the elimination method are now converging. After you get here, you have one equation, factor to solve just like you would above. Okay? So how would I factor? This is that multiply the first and last numbers together with a little x, right? We're going to get a relatively big number. I can't remember what it is. Negative 208 and then negative 3. So I need to find numbers and multiply to get negative 208, but add to get negative 3. Now there is a way you guys can use your calculator to do this. I don't know if your previous teachers have taught you guys. If you guys go into your calculator and you hit the y equals window, and then you type in negative, like 2, y equals negative 208 divided by x. You do that in your graphing window and hit second graph. It gives you a table of values. You can go through the table of values, those little numbers, until you find the ones to add to get 3. Just makes it a little easier. Yes, negative 16 and positive 13. So if you're not a factoring guru and you would like to just see what your options are, use that little trick in your calculator. You go to the y equals and you type the number you're trying to factor, divided by x, and hit the second graph, and scroll through the numbers. Alright? So something you guys should know is 0, right? 4x squared minus 16x plus 13x minus 52. It's just regular factoring. You just pick up from here and go. What would I do next? Okay. Did that.
4x.
And okay. 10. Yeah, you get 13. 52 is 13 times 4. So when you pull that out, you have a negative 4 left over. So I know I did it correctly because the parentheses are the same. My final factors are 4x plus 13 and x minus 4. Remember, all this is still set equal to 0. So how do I find my x values? You're going to set each of these equal to 0. And get the x values. So I get x equals, as a decimal, negative 3.25. As well as positive 4 from the other factor. Just do negative 13 divided by 4 in your calculator, you get a decimal. Yes? I would rather have it as a decimal. Alright, so done, circle answer, move on. Now I have to find the y. So I'm going to take my y value, or sorry, my x values, these guys, one at a time. People do that sometimes. Take one at a time and plug them into your favorite equation. It could either be one of the ones that were printed for you or one of the ones that you created yourself. It's usually safer to do the ones that are printed because if you made a mistake rewriting them, then your answer would be wrong with y.
You have to use the 4 y equations, right?
You can use whatever one you want. It would probably be easiest to do because it's just y equals, so if you just plug x in, then you get it automatically, right? It's a little bit of strategy to think about which one would be easier. So if I take negative 3.25 and I square it and then subtract 16, what do I get?
It's 46. Oh wait.
Negative 5. Negative 5 times something.
Parentheses.
Yeah, don't forget, if this is negative and you're squaring it, you need parentheses. if you're squaring something that's negative. So one of my, yeah, I think I rounded it. I rounded it to that, 2 decimals, and then when you plug in 4, what do you get? 0. Because if you plug in 4, 4 squared is 16 minus 16 is 0. That part's not hard, guys. It's literally just plugging a number into the calculator. Okay, so I expect you guys to be able to do that. So once I find the y's, I just match them up, write them as a point. So one of my points would be this one, and my other point would be one. Make sure you match the x's and the y's together. The x that gives you a particular y, they need to be in the same point. So that would be my first one. Alright, so again, I love the elimination method, but for some people it's really just not their cup of tea. But I will say that the elimination method, you have to use it for these scenarios where you try to divide by the coefficient to get a fraction. So you need to know how to do it. You guys can use substitution method as much as you want for everything else, but you need to know this method because it's what you have to use if this is the scenario that you run into. Okay. Alright, what about this one? Have they been arranged that it's y on one side and everything else on the other? Nope, we have to take care of that. So for this one, all I need to do is add the x squared over it. And what I'm going to do, see how everything's kind of jumbled up on this side? I'm going to write it in standard form. So I'm just going to rearrange everything.
X squared minus 5 minus 1.
Yeah. I'm going to shuffle everything around so that it's in standard form once I move the x squared over. I'll make it easier to work with. Okay, I'm going to cross this one out. So that one looks nicer. And then what would I do to rearrange?
Plus 8x.
Okay, I'm going to leave the 4y alone. That needs to stay on the left side. And I'm going to add the 8x. So I'm going to make sure that it is underneath the negative 5x. You guys see how I'm stacking them so they're like terms. And then the negative 21 is over here. So I have this blank spot right there where there's no x squared. Alright, if I tried to divide the bottom equation by 4, would that work out for us? No. So this is the situation where, again, you're going to have to use elimination. Okay? Right. So now, once you rearrange everything, now you need to figure out how do I make the y's opposite. You have to multiply the top equation by negative 4. Right? If the bottom one is positive 4, so I want the top one to be negative 4 so they cancel out. So then I multiply everything up here by negative 4. That gives me negative 4y, negative 4x squared, plus 20x, minus 28. And then you write the second one without changing it. Change the top one, leave the bottom one alone, because it was perfect the way it was. Does everybody see where we are and how we got here? Alright, what next?
Add down.
Add down. That's the whole point of the elimination method. Having these two being opposite means that when we add down, they cancel out. Then we're going to do the same thing down each column. Do I have anything to add with the x squared?
Yeah.
So this stays negative 4x squared. Then I have 20x plus 8x.
28x.
And then I have negative 28 plus negative 21.
Negative 41.
Negative 49. Okay, so now I'm here. And again, you should see this is a trinomial in standard form, so I'm going to be using factoring to solve, just like normal. Is there a DCF?
No. Or negative. Yeah.
The negative. The negative is a DCF. And then what's left in the parentheses, now I'll correct it with the signs and everything. That's what I get to solve. I'm going to do a little F over here. So what happens in order to factor?
4 times 20.
4 times 49. Oops, I did it backwards. Okay, and then another number negative 28. Again, big number. So if you're not a factoring guru, like I said before, you can use your calculator to help you. You're going to the y equals window. You would type 196 divided by x, hit second graph, and look through all those options that you have there for 2 whole numbers that would add to get negative 28.
14 and 14. Or negative 14 and negative 14.
Yes. negative 14, negative 14. Okay. Always confirm, like multiply them and then add them, make sure that you get the two numbers in the part of the cross for the answer. So then I would have 4x squared minus 14x minus 14x plus 49. And this is all stuff you guys you should know because we did this last unit very recently. Split. GCF on the left.
Or, yeah,
2x. Leaving behind 2x minus 7. What's the GCF on the right side? Negative 7. I know I drew it a little bit small, but that is a minus right there, so that is part of your GCF. Minus 7. This would leave me 2x minus 7 as well. So what would my final factored form look like?
2x minus 7, so 2x.
So what does that imply about this scenario? There's really only one solution, because you have the same x twice. So once you set them equal to 0, what is that x value that's repeated?
I think 3.5.
3.5. You add the 7 and then divide by 2, you get positive 3.5 if you're using the decimal. And then I need to find the y value that goes with that. So again, you're going to take your 3.5 and you're going to plug it into your favorite equation up here. Probably this one would be nicer because it's already set up as y equals. So you do 3.5 squared minus 5 times 3.9 plus 7. And again, this is on your calculators. Type. You should get a decimal, but it should be a whole, like, it stops. Yes. 1.75. So your answer, you have to write it as a point, would be 3.5, 1.75. Okay? They're both the same. You get the same x value, that's why I only write it once. You don't be repetitive. Okay? Alright, just like before, I'm going to have you guys do the third one by yourself. For this one, you should have gotten 1, negative 1, and as decimal approximation, 4.3 and 5.9. If you want to use two decimals, it's fine. But approximately 4.3 and 5.9. Okay? So again, for this one, for factoring, it would have been the trinomial with the x process, just like we did for the previous two. Slightly smaller number, so hopefully that's a little bit easier, but you would get two solutions for this. Okay? So you can write that down again if you need to discuss that one with me individually. Feel free to do that after we wrap up. Okay, that's what? The secondary answer? Or the y value?
Yeah.
With a 4.3? Yeah. Oh, wait. Yeah, that's weird. Yeah, I don't know why I wrote that 5.6 written off the side and 5.9 is point. So that's kind of weird. Yeah, 5.6. More likely. I don't know why I wrote that. Alright. So anyway, that is kind of our introduction. So the graphing is one method, and then you have your algebraic methods with the substitution and elimination. Substitution will work in most situations. Like this one, you could have used substitution for this one, couldn't you, Ocean? Because it had y equals and they were just no coefficients, you could have used the substitution method. But for these first two here, you have to use the elimination because you cannot get rid of the coefficient. So that one, it's important to know how to use the elimination for those scenarios. So, before we move on, I need to introduce the small project that you guys are going to be doing throughout the unit. So you guys will need your computer out for that. If you guys just want to have one computer per set of desks, that's fine too. I just need you guys to kind of see it, kind of experience how to navigate through the technology. So you guys are able to do it by yourself. No. there's a link on Blackboard, so I'm going to give you guys a few minutes to get onto your computers, and then you're going to go onto Blackboard. There's a link there. So again, this was our sample. Now we're going to do this one together, all right? So what you guys want to do, I'm going to do this one with you. This is what you're going to be doing on your own when you guys move on from this sample example. Yeah, sample. All right, so you guys are going to go into Desmos. You're going to clear everything. You guys, this is very experimental. So you guys want to experiment with a line, an equation of a line, and an equation of a quadratic so they only intersect once. So let's say I randomly type in y equals x squared plus 2x minus 1. So you start there randomly. If I do square, you're going to hit Shift 6 with a little caret. Shift 6. No, to get down, you just push the arrow button to the right. So let's say that is my, you can make whatever quadratic you would like. Make up random quadratic right now. Now, what do you think would be the equation of a line that would only cross this guy once? Can you visualize it? Where might that line be? This one? See it like right there with the -1? Alright, if we think that the y-intercept would be a -1 for that guy, I need to figure out what the slope would be. So we'll experiment, right? So that's -1. I know. Okay, so listen. The one that I picked here, how many times does that hit the hit the quadratic function? Twice. That's not going to work. So how can I fix this so it only touches once? Okay. So this, you did 5? Okay. Well, actually, so this one's not good because it'll hit it again up here. You gotta be careful. Sometimes it'll look like it doesn't hit, but it actually does a little bit further up. 3? Nope, it hits twice. One's here and one's here. When I went to 2, you guys, if you're not sure, you can zoom in. If you zoom in a little bit closer, do you guys see how that right there is an intersection? If you're not sure, you can do that. So right here, this is the line that only touches it once. It only has that one intersection right there. Feel free to zoom in so you can tell. If I zoom in real close, that's the only spot that is going to intersect the quadratic. So that's the equation of the line that I'm after. Osmond, you should be at your desk, please. Alright, so this is what we've come up with. This is the quadratic and the linear that would only intersect once. So you're going to go back here, alright? I'm going to need to enter that system in here. Now the way you're going to do that, this is where the technology might get a little funky for you guys. If you go back to this example slide right here and hit this link, it's going to take you to this really cool programming thing where you can type it in and it'll look all fancy like math type, where you can type an equation and it looks all nice and pretty, okay? The way you're going to do, I'm recording this right now, so if you guys need to go back and see this again for instructions, it will be available for you in the video. To create a system, you need to go into this very last box right here and hit this little squiggle thingy with 2 lines. Squiggle thingy, you're going to go to the N over R, and then go to the squiggle thingy with 2 lines here. They want to know how many rows you want, so because we have 2 equations, you're going to have 2 rows but only 1 column, and hit OK. Yes, look at this. So again, you go into this little guy right here, you hit the little squiggly bracket with 2 lines, and then it'll pop a little box up. You hit 2, 1 because you want 2 rows, 1 column, then hit enter, and then this pops up, okay? So all you guys need to do now is type in the equations that you guys got from Desmos. So my first equation was y equals x squared. Again, if you hit Shift 6, it gives you the caret. What was the rest of it? Plus 2x minus 1. That was my first equation. That was my quadratic one from Desmos. Okay? Then, you see these little two little slanty things? Go go to the other side of this landing page. These two little, what are they, dashes? Slashes. I don't know. You're going to go to the other side, and that's where you're going to write the second equation. Y equals 2x minus 1. See how pretty that is? And all you guys have to do is copy, paste. Yeah, right click. And make it a little bit bigger so I can see it. Ta-da! Yeah, so you just right click, copy, go in here and paste it. It's going to be super small, so just click and drag to make it bigger. Alright, and that's what your first slide should look like. You would say problem 2, tell me what kind of system it is, how many solutions it will have, and plug it in. Okay? That's fine. I'll be able to just make it so that I can sort of kind of read it. Yes? You can use this example if you would like, yes. Alright? Then you guys need to create another slide. This is going to be problem 2 answer key. Problem 2 answer key. Or solution, you could either answer key or solution, doesn't really matter. This is where you guys are going to take a screenshot of the graph and drop it in here, and then physically write down what the solution would be. So if you go back to Desmos and then use whatever screenshot program thingy you're going to use. And then you do the same thing, you're going to copy and paste that in. Make it a little bit smaller. And I need the equations over here as well as the graph in your whatever it is you're using. Right? And then just to wrap it up, I need you guys to physically write down somewhere what the solution is. You can even type it up here if you want to. What was the point of intersection? What was the solution? Go back and check really quick. What's the solution? Where do they cross? 0, -1. You can type it down in the title. You could put it in a text box somewhere. Wherever you'd like. I don't really know how to work with this that well, but wherever it is you can write down what the point is as an actual ordered pair, you would do that. Here, off to the side, whatever you guys want. On the answer key or solution slide, you need the picture from Desmos and the written ordered pair. And that would be 1. Okay? So that's an example. For you guys, for your homework, in addition to doing the problems that is on the document posted on Blackboard, just like you would normally do, I want you guys to do 2 more sets. You need to do a linear quadratic with 2 solutions and a linear quadratic with no solutions. So if you guys want to set those up right now, problem 3, linear quadratic, 2 solutions, and then you can do that one later. And then problem 4, linear quadratic, 2 solutions. In addition to your written homework, I want you guys to create 2 more pairs of slides, the problem and the answer key, for a linear quadratic with 2 solutions and a linear quadratic with no solutions. Okay? And then we'll repeat that. Did I spell quadratic wrong? We'll repeat that as we're learning different types of systems. We'll do the same thing each time you learn. Okay? So again, this is saved in your drive, your Google Drive. You've made a copy. It's now yours on your computer. Make sure you rename it so your name's in the title. It should save everything that we've put into it already, and then you would just continue to work on it bit by bit as we go through the unit. Okay? And again, this was recorded, so if you need to revisit, you guys can go look at the recording at the end of the lesson.